In this example, we're going to consider the method of trial and improvement. You may wonder why we would use a trial and improvement method to solve equations. The simple fact of the matter is that not all equations will solve algebraically. In that case, we need to use a method such as trial and improvement to get a solution. The equation x squared plus 3x equals 14 has a solution between 2 and 3. We want to find this solution correct to one decimal place using a trial and improvement method. When performing this method, I like to keep my information organized in a table. The first column of this table is x. This contains the current value of x I'm investigating. The second column here is x squared plus 3x. Note the equation is x squared plus 3x is equal to 14. The third column contains a comment. We're told the solution is between 2 and 3. Start with x is 2. 2 squared is 4, plus 3 2's, which are 6, gives us 10. Compare with 14, and this is too low. Try 3. 3 squared is 9, plus 3 3's, which are 9, giving us 18. Compare with 14, and this is too high. The next thing to do is try a value between 2 and 3, such as 2.5. We calculate 2.5 squared plus 3 times 2.5. This gives us 13.75, which is less than 14, so it's too low. Let's try 2.6. We're calculating 2.6 squared plus 3 times 2.6. This gives us 14.56, which is too high. Since 2.5 gave us too low and 2.6 gave us too high, we know that the answer is between these two values. We're supposed to give the answer to one decimal place, so the answer will either be 2.5 or 2.6. Let's investigate further using a number line. 2.5 was too low and 2.6 was too high. If we look at halfway, which is 2.55, if this proved to be too high, the answer would be in this region, closer to 2.5. If 2.55 were too low, the answer would be in this region, closer to 2.6. What we have to do is check 2.55. We calculate, and we get 14.15 and so on, which is too high. So this is too high, meaning the answer is in this region here, which is closer to 2.5. So our answer is that x is equal to 2.5, correct to one decimal place. A common mistake here is to look at these two values. 13.75 is closer to 14 than 14.56, and many pupils choose 2.5 on that basis. But this is not correct. We're not dealing with straight lines. Unless you actually check the value 2.55, you won't receive full marks for a trial and improvement question, whether or not you draw the number line.